Leetcode 76, minimum window substring. It's a hard problem, but don't get discouraged. I would say that it's an entry-level hard, if there is such thing. So definitely don't get discouraged. If you can tackle on your own mediums, then you should be able to try, at least give it a try. And here is the description. Given two strings S and T of lengths M and N respectively. And so basically we have two strings as an input, and they have meaningless names, but the first one is supposed to be this bigger one, and we should try to find the second one, occurrences of the second one in the first one, but not necessarily the way we were used to doing it in mediums and easy. So there is like a slight change, and you will learn about it in a second. So return the minimum window substring of S such that every character in T, including duplicates, is included in the window. Yeah. If there is no such substring, return the empty string. Yeah. So it could be the case that there is no such substring. So we don't want to have a perfect match or to find indices where the substring occurs in the string. We want to find a substring of S which might include some additional characters, but it should be the least or should have the minimum length. This is the minimum window, and has to include each character from T. And the additional level of difficulty is given by the fact that it can have duplicates. Yeah, so you have to keep track of each character separately, and the characters can be duplicated in T. The test cases will be generated such that the answer is unique. Yeah, so there won't be such case where we will have multiple minimum windows of the same length. Yeah, so if there's a minimum window, they guarantee here that it will be just this only one. So we can basically look for it from any side, either from left to right or right to left. And here is the first example. So we have this big string, A, D, O, B, E, C, and so on. And we want to find ABC. And there is no just ABC anywhere here, but there is B, A, and C. And first thing that you can notice is that this string has greater length than the substring that we are looking for, or the other string that we are looking for. And because that one is actually the actual substring. Because we can have additional characters. That's what we said. But the next thing, before we go to the but, the next thing is that the characters don't have to appear in the same order. We just need to have such a substring that has all those characters. And for example, if there's a duplicate like C 2 times, then it also will have to be included this 2 times. Yeah, and once we take it from here, this is of course a substring. It has to have the same order like in the original string. It's like a sub part of it without changing anything, and we have to return it. So no indices, nothing like this. The answer is also a string. The minimum window substring B, A, and C includes A, B, and C from string T. And the second example is like slight an edge case, because of course the string itself, it's also its own substring, and the second string could also be equal to the initial string. Yeah, and in this case, everything is equal to the same string because there's no other option. The entire string S is the minimum window. This is also could be a case. And the second case is that the second string, which I said that is like this smaller or the shorter of the two, could be also actually bigger, but in this case there wouldn't be any possible answer. Yeah, because if this one is bigger than this, then we will not find anything here. That could be a possible solution. Both A's from T must be included in the window. Yeah, so each duplicate is treated separately as its own individual character. Since the largest window of S only has one A, return empty string. And that's it. And of course, here we return empty string, which is the case when we have no answer. And follow up, could you find an algorithm that runs in all m plus n time? I'm not sure if we will have it, but I think yes. I think that we should be able to have this type complexity in our solution. So let's get into it. Let's copy this, since that was an interesting example. And we can make it slightly bigger. And we can also copy the title. And basically, in the first, already in the title, you have the first hint window, which usually hints at what? At two-pointer strategy. 2 pointers. So we will have 2 pointers, one of course from the left, the other from the right, and together there will create a window. And we will be able to find the substring if it exists in a single pass using this technique. 2 pointers, and we can write to the left and right. And basically, maybe first, let's try to do it on the graphical level, and then I will try to explain it better with words, and then we'll convert it to code by the end. And let's use those arrows as our pointers. So the blue one will be our left pointer, and the green one will be our right pointer. Yeah. At the beginning, we will have them both set either to -1 or to 0, but probably to 0 is better. And then we will try to extend the right pointer as far to the right as possible, however it sounds. Yeah, up until we will for sure include all the characters from T in the window, and then we'll try to shrink it by moving the left pointer. Yeah, so first we will try to move it to the right one by one, so on, so on, so on, so on. And here, finally, here all the characters are there. And no, sorry, there was one before. And that would be the first substring that we would find. And then we would try to shrink. But in this case, in this first case, we cannot shrink, since shrinking is only allowed when we will have too many characters. Yeah. So in this case, all the necessary characters are already at the edges, and we cannot shrink. So the only option is to try to find a better window. Yeah? And we'll try to find a better window basically by moving first left and then moving the right. And we will move it again up until we have all the characters. Now we have another window which is possible, but this one is even worse than the previous one, and we'll try to move it like this. And the next one that we'll find is this one, which is the best. And so that's visual representation of what we'll try to do. And now let's try to make it a little bit more concrete. Yeah, so first thing was to move the right pointer there one by one to the right. Till we will include all the necessary characters in the window between left and right. So that will be the first thing. Then, when we'll have it, we'll try to shrink the window, if possible. That could be impossible, like it was the case with this first one, by moving the left pointer to the right. And that's the algorithm, by the way. And now we have a window. Yeah, so we have to keep track of some best possible windows. Yeah, so keep track of best window shortest found so far. Yeah, and the fourth, then move the left pointer to the right by 1, or increment. Let's simply increment. By the end, increment the left pointer and the 1, and repeat up until there are no more windows to try. So up until we reach the end of the string with the right pointer. So for sure, we will have to pass at least once. Yeah. And then go back here. Till right pointer reaches the end of input string, of the input string S, till the right pointer. Till we, and we will repeat it a couple times, probably, depending, of course, on how big this input string is, and we will try to find the best possible option. Okay, so let's try to convert it to the code now. And what do we need? We need left. We need best left and best right. We need to iterate through our string using right pointer and the character. So we'll iterate character by character through string S in enumerate. And basically enumerate gives you both index and the element of your collection. And in this case, it will be character of the string. And now we will have to somehow be able to tell if we have already found, or if we have already if there are already all the necessary characters from T inside our window. How can we tell it? Okay, so that's the next question. How to tell if all the characters from T are in the window? I will need to use some additional variables for this. And we can use counter, which is like a modified dictionary, which is something like a histogram inside Python. So there is this additional data structure called counter, which will let's use counter, which will keep track of how many characters we how many repetitions, maybe like this, of each character from T there are initially, and how many we used so far. And we will also use an additional variable that will allow us to not always iterate through it to check if we have found already all of them, we will use a variable called, don't know how it's called, we'll think in a second, additional variable equal to the length of t, which we will decrement each time we find a new character from t in the window. Yeah, like this. So I think those two we will use. So let's first use the counter, create the counter. I think we need to import it from collections, import counter. Yeah. And once we pass the string to it, it will automatically create something like a dictionary. I think it uses a dictionary under the hood, and and will keep track of how many times each character appears in T. Yeah, so for example, if A appears 5 times, it will put value 5 on key next to key A. Yeah, that's how it works. So basically, it's a histogram which works out of the box. And the second is this variable equal to the length of T, which we can call missing or found. Let's say missing, because initially it will have all the characters, and once we will be finding them, we will be decrementing. And now let's do it. So if the value for given character stored by the counter is greater than 0, that means that first of all, this is the character from the original from the string T, and second of all, we have to decrease it in our missing variable by 1. So we have found one more character, and the thing is that inside this window we can have more occurrences of a given character than needed. Yeah, so then we don't want to have false positive. That's why we check like this. And if, for example, we only look for one A, but there are multiple A's inside, we could be decreasing this too many times if we didn't guard it against such a situation, using it like this. And then we can decrease by 1. And if missing is equal to 0, that means, so basically at this point, we are just moving the right pointer, and here it's time to move the left pointer. We have found all the necessary characters. Yeah, and at this point we'll try to shrink the left at the window by moving the left pointer. Yeah, so while left is left and right, and our counter has the reverse or inverse relation. Yeah, so if we have less than needed, yeah, so maybe we have found multiple A's as we discussed before, then we can only move the pointer if we have still the counter is for given character is less than 0, and the character that we are currently considering is S on position left. and because we are moving now the left pointer. And now we can remove it, and we can move the left by one. And of course, because we are removing it, sorry about that, we have to increment here. Yeah, since we have removed it from the given window, so we were incrementing, we were decreasing once we were finding, and now we are increasing once we are getting rid of this, getting rid of those characters. Yeah, and after that, if either this or this, the other condition is false, that means that we cannot shrink anymore, and we can try to update the global best left and right. Yeah, so basically best left and right can be swapped with current left and right, but only if current left and right are better, meaning that right minus left is greater than what we had before. Best left minus, and the window, only if the window is bigger. That's it. And now we can try to we have stopped, like here we were shrinking the window to be still a valid window, and now we start looking for the new window by moving left by one to the right. So now we are looking for a potential new window. And we also have to increment missing by one. Yep. How do we know about this? Because the left was on the last missing character, since we moved it here to be on such place. And that's it. And by the end, we should have the best possible window here. So we should return that substring. And let's try and run it. Runtime error. Name character here. I don't like the fact that it doesn't highlight syntax errors before running, so you have to discover it all first once you run it. But that's it. Okay, so no more syntax errors, but some logical errors, it seems. Let me try and check. And I think that the problem is here, because our slice here is exclusive. So this right is not included in the slide, but in the slice. But here we use right pointer inside our window, so we will have to add one basically here. Or the other option is when the best right still equal to 0. So let's try now. And we solved one case. This one is still wrong. Let me think. And maybe we have to do like this. No, this shouldn't be the case since the OR will work in either case. Yeah, it's not this. Let me think. And here. We want the smallest window, and let me just take a look at everything else. And yeah, since we said about this exclusive and inclusive here, we also need less than or equal. Check the rest. Okay, now I don't see anything else. Maybe there are still some issues, but now we have at least get the first cases correct, and even all the cases now work as once we have corrected those slight mistakes. Let's try again just to see how varied are the test cases. And now we beat 80%.